today's class is limits and continuity based on applied mathematics CBSE Code 241. So there are some standard results. First we discuss with the standard results. Limit x tends to 0 e raised to x minus 1 by x is equal to 1. First, I will give you some problems, then you will understand the result. Okay, first question is limit x tends to 0 e power 5x minus 1 by x. So how to do this problem? So you check with the standard result and match with the standard result. So there is e raised to x minus 1 by x. See what is the power of e, that should be in the denominator. So e raised to x, same x. If it is e raised to y, the denominator should be y. So here e raised to 5x, so denominator should be 5x. There is no 5. E raised to 5x minus 1 divided by, so multiply by 5 numerator and denominator. So this is okay with the standard result, right? So that answer is 1, and 1 into 5, so final answer is 5. Okay. The second question, e raised to negative x. So there is no negative x in the denominator, so multiply the denominator by negative. So the question changes to limit x tends to 0 e raised to negative x minus 1 divided by, multiply the denominator by negative, so multiply the numerator by negative 1. So this part will be according to the standard result to 1, and that 1 into negative 1, so final answer is equal to negative 1. Okay. Another problem, limit x tends to 0 e raised to x minus e raised to negative x divided by x. So what happens? Limit x tends to 0, the standard result is e raised to x minus 1 by x, so there should be 1, but here it is e raised to negative x, so change, e raised to negative x is equal to 1 by e raised to x. So our question reduces to limit x tends to 0 e raised to x minus 1 by e raised to x all divided by the same x. Then there is an LCM, e raised to x into e raised to x, e raised to 2x minus 1 all divided by e raised to x. Already denominator there is x. So limit x tends to 0, we just arrange this, e raised to 2x minus 1 divided by x into, move this e raised to x to right side. So what happens? E raised to 2x minus 1 by x. Here e raised to x minus 1 by x. The power is 2x. There is no 2x in the denominator. So multiply denominator and numerator by 2. Limit x tends to 0. E raised to 2x minus 1 by multiplication, that is 2x. So into 2 in the numerator, the e raised to x remaining there. Then you can apply this standard result here. Then you need not write limit x tends to 0 again. So this part will be 1 into 2 by e raised to 0, because x is equal to 0. and e raised to 0 is equal to 1 because any number raised to 0 is equal to 1. So finally 2 by 1 and that is equal to 2. So this is the answer. Okay, I will explain again. E raised to x minus e raised to negative x by x. So when we match with the standard result, there should be 1. So e raised to negative x is equal to 1 by e raised to x. So finding LCM, e raised to 2x minus 1 by e raised to x into x, e raised to 2x minus 1 by x. Move this e raised to x to right side to get the standard result. So e raised to 2x minus 1 by, there is no 2 in the denominator, so multiply it by 2. So this part will be 1 and 2 by e raised to 0 because the value of x is equal to 0, and you know e raised to 0 is equal to 1. So finally 2 by 1, that is equal to 2. We will do another question. And that is limit e raised to x minus x. So limit x tends to 0, e raised to x, take this minus 1 first, so divided by x. So we can arrange the numerator according to standard result. So limit x tends to 0, e raised to x minus 1, group these terms, minus x divided by x. So we can split e raised to x minus 1 by x minus x by x. So that becomes limit x tends to 0, e raised to x minus 1 by x minus x divided by x, that is 1. So this part, this is exactly the standard result, value 1 minus that 1 minus 1, and that is equal to 0. So how to find the limits of these problems according to the standard result? So you arrange the question as according to the standard result, then you apply the result, then you will get the answers without any difficulty. I think all of you understand these methods. Okay, thank you for good listening. Thank you.